Topic 2, percentage and absolute uncertainty. A student measures the mass of an object to be 75 plus or minus 2 grams. So what is the percentage uncertainty in this measurement? So what should you do? Percentage uncertainty in the mass of it, which you need delta m divided by m multiplied by 100. So what is the delta m value? 2. And what is the value of m, which is 75? So therefore, if I calculate this value, let me take up the calculator over here. Okay, just give me a moment. So this should be 2 divided by 75 is equal to multiply this by 100. If I get this as 2.67 or 2.7 percentage, the answer should be C over here. Okay, now let me take up the next one. The speed of an object increases from 15 plus or minus 1 meter per second to 25 plus or minus 1 meter per second. What is the percentage uncertainty in the change of speed? So look at this, it's asking about the change of speed. So this is your V1 plus or minus delta V1, and this should be V2 plus or minus delta V2 over here. Okay, so what is he asking here? He is asking you, let me call this as VA here, and let me call this as VB over here. He is asking you what is the percentage uncertainty in the change in speed. First write down the change in speed over here. So we will say V change is equal to VB minus VA, VB minus VA. Okay, and if I am doing this one here, then what will be the uncertainty here? The uncertainty here will be added up, okay, which will be delta V1 plus delta V2. What is delta V1 over here? 1, and delta V2 is 2. So 1 plus 1 over here. I am not going to subtract them because errors cannot be subtracted. You need to add them. So therefore, VB minus VA would be 25 minus 15, which should be 10 plus or minus 2 over here. This should be your VC. Now you need to calculate the percentage uncertainty for this value. What is this now? I can now write delta VC by VC is multiplied by 100, which should now be equal to 2 divided by 10 multiplied by 100. So you get this as equal to 20%. So answer should be 20%. D is your right answer. Okay, next. The radius of a sphere is measured as 5 plus or minus 0.2 centimeter. What is the absolute uncertainty in the volume of the sphere? Absolute uncertainty. Okay. So therefore, you need to calculate what is the value of delta V. So to do this, first we will calculate V is equal to 4 by 3 pi r cube. This is what we need. Okay. So therefore, see all the numbers are different over here. We need to just calculate only the value of delta V, nothing else. So therefore, now what we do is let us take delta V by V over here from here, which should now be equal to 3 times delta R by R, right? Because this is a constant, I'm going to write like this, which should be 3 multiplied by what is delta R? 0.2 centimeter divided by R value is equal to 5 centimeter, right? So just identify this. This is your R and this is your delta R. So when I do this, let me take up my calculator once again. So this should be, let me cancel this initially, and then I will write 3 into 0.2 divided by 5, which will now be equal to 0.12. So I have got 0.12 here, but this is not the end of it. So I need to calculate the value of delta V. So what I should do is I will now do something like delta V is equal to 0.12 times V. What is the value of V? V should be 4 by 3 pi into what is the R? R value is 5 cube, which is 25, 125 over here, 125 over here. So therefore, I am going to multiply all of them and get the answer. So this would now be, let me take this value, 0.12 is already there. I'll take this value, multiply this by 4, divide this by 3. So I have got this multiplied by 3.142 multiplied by 3.14 multiplied by 125 multiplied by 125. I get the answer 62.8. None of the answers are closer. Let me just find out what went wrong. So 5 cube, 5 into 5 into 5 should now be 125. This is correct. Let me just recheck my answers. 0.12, 4 by 3, 3 into 0.2 divided by 5. So that's right. Delta V is equal to 0.12. multiplied by 4 by 3, multiplied by 4 divided by 3. I think I made a mistake somewhere over here. Let me recheck this once again. 0.12 multiplied by 4 multiplied by 3.14 multiplied by 125 divided by 2. I get this as 62.8. Delta V should be equal to 62.8 only. Cannot be more or less. Okay, let me keep this apart. We'll do the fourth one. Question number 4. A rectangular field has a dimensions of 25 plus or minus 0.5 meters and 40 plus or minus 0.5 meters. The dimensions are given, which means length and breadth are given. What is the percentage uncertainty in the area of the field? Okay, so therefore, first let us draw the diagram over here. So it is like this. So length is seen to be 40 and breadth is seen to be 25. And then it is asking you to find out what is the percentage uncertainty in the area of the field. So how do you calculate area? Area is equal to length multiplied by breadth, right? So therefore, now if I take delta A by A, relative uncertainty of this, I can now write this as delta L by L plus delta B by B. Okay, what is delta L by L? Delta L by L is 40.5 divided by 40 plus delta B by B will now be equal to 0.5 by 0.5 by 25. Okay, let me use the calculator to get the final answer, which will now be equal to here 0.5 divided by 40 is equal to so much plus 0.5 divided by 25 is equal to 0.0325, and this multiplied by area. What is the area value? Area is L into B, which I multiplied as 25 into 40. Multiply this by 25, multiply this by 40. I get the answer as 32.5. 32.5. So, oh sorry, I need delta A by A here. I just need this value here. Why do I need delta A here? Delta A by A into 100 I need, which should have been, I need not do this value, I should get 0.0325. This should be equal to 0.0325, 0.0325, but I want the percentage uncertainty. If I multiply this by 100, I get this as equal to 3.25 percentage, which is nearly 3%. Answer is D. Let us move on to the last question in the series. A student measures the time for a pendulum to complete 20 oscillations and as 32.5 plus or minus 0.5 seconds is the time taken for 20 oscillations. What is the percentage uncertainty in the period of one oscillation? So percentage uncertainty in one oscillation. So if I get 20 oscillations over here, the time taken for one oscillation would be 32.5 plus or minus 0.5 divided by 20. So this is what I get here, right? So which should now be equal to 32.5 divided by 20 plus or minus 0.5 divided by 20. I'm not going to solve anything over here. Without that itself, let us see. So therefore, now what do I need here? I'll get some number here. Don't worry about that number. We can use your calculator to get the answer. Next, what I need is I need a delta T divided by T. What is delta T by T? Which should now be equal to, what is delta T? 0.5 divided by 20 divided by 32.5 divided by 20. So this 20 and this goes away. So therefore 0.5 divided by 32.5 should be your answer. So let me calculate this to get the final answer here, which should now be equal to 0.5 divided by 32.5, which will now give me 0.015. We have got the relative uncertainty here, which is 0.015. If I take percentage, I need to multiply this by 100. So I get 1.5%. Answer should be B over here. Okay. So with this, we come to an end to this particular exercise, which is this percentage and absolute uncertainty, and we'll see the next exercise in the next video. Thank you.